Hi, Chem Peeps. We're going to find oxidation numbers inside compounds. We're going to use the cross-up method. So looking at our first example here of silicon dioxide, I'm going to look at the subscripts that are in the formula. There's a 1 for the silicon, and I'm going to cross the 1 up to above the oxygen, and I'm going to take the 2 that's down here and cross it up to the silicon. My first element will always be the cation, so it'll be positive, and my second one will be negative, which is my anion. We're not done. This is the step that we got to remember to always check the one on the right. It will follow the periodic trend because it is the most electronegative. So looking at my chart here, I'm coming up to the trend. Oxygen is in family 16. It's normally a -2, not a -1. So I must multiply by what will give me what it typically is, which is going to be multiplying by 2 to get a -2 charge. But what we do to one side, we must do to the other. So 2 times 2 is +4, and so silicon is a +4, and oxygen is a -2. Let's go over here to the copper and oxygen. You can see that there are no numbers here, so we assume ones. I'm going to bring a 1 here and a 1 here. The first one's positive, second one's negative. We know from our last problem that oxygen is normally -2, so this ratio must be unreduced. So 1 times -2 is going to be a -2 for oxygen, and what we do to one side, we must do to the other. So the copper in this example is a +2. This is a common mistake students make. They assume that since the subscripts are 1, that it's going to be copper 1, but indeed it is not. It is copper 2. And so that cross-up method will allow us to clarify which one it is. So let's go to our next problem, which is going to be the titanium and the oxygen. We have a 1 that we're going to bring up for the oxygen, a 2 for the titanium. First one's positive, second one's negative. Check the one on the right, which we've been checking oxygen. We know that it needs to be a -2. So 2 times -1 gives it that -2. But what we do to one side, we must do to the other. So the titanium is a +4. Titanium is not in my typical common list. So this cross-up allowed me to determine that this titanium is a +4. And that's where this method is very useful if it's not something common or trend following. Okay, let's go to this aluminum and sulfur. We're going to bring a 2 up to the sulfur and a 3 up for the aluminum. Aluminum is going to be positive. Sulfur is going to be negative, but we're going to check it. And it is in the same family as oxygen. So it is a -2. And it is a -2 here. So this is done. We have a +3 for aluminum and a -2 for sulfur. The last one, if you notice here, these parentheses, first of all, this compound has more than 2 elements. So that's a giveaway that this is has a polyatomic ion in it. And indeed, NO3 is going to be our nitrate, which is up here on that chart. And if you look, nitrate is normally a -1. So let's look and do cross-up. When you have a polyatomic ion, do not cross up that 3. That belongs to the formula. That's part of its identity. You cross the number up that's outside the parentheses. And if there are not parentheses, it's assumed to be a 1. So we're going to bring the 2 up to the magnesium, and then magnesium, having no number, we're going to cross up a 1. The first one's positive, the second one's negative. We already determined that nitrate is supposed to be a -1. So NO3 here has a -1 charge, and magnesium has a +2 charge. And that's how you do cross-up for compounds. Check me on my video to see other information on ions and determining their charges. I'll see you soon.